Hey YouTubers, thanks for joining me here. Another video of random chemistry. In this video, we're going to continue practicing mole-to-mole conversions, and we're going to start with this equation right here. P4 reacts with 6Br2 to yield 4PBr3. And the question is, how many moles of P4 must react to produce 7 moles of PBr3? The first thing we need to do is identify our molar ratio. We need the molar ratio of P4 and PBr3, which is 1 to 4. So I'll write that as a conversion factor. 1 mole of P4 for every 4 moles of PBr3. And then remember that we can write that inversely. 4 moles of PBr3 for every 1 mole of P4. And we'll use dimensional analysis to solve this equation. So we'll start with what we're given. 7 moles of PBr3. 7 moles of PBr3. I have moles of PRB on top, so I want moles of PRB on bottom to cancel them out. So that means I'm going to use this conversion factor. So moles of PRB cancel, and I'm left with moles of P4, which is what the question is asking me for. So then I just do my math. I plug this into my calculator, 7 times 1 divided by 4, and I get, 1.75 moles of P4. So 1.75 moles of P4 must react to produce 7 moles of PBr3. Alright, here's another practice question for the same chemical equation. How many moles of PBr3 are produced when 22 Br2s react? So first we need to find our molar ratio for PBr3 and Br2, which is 6 to 4. And I'll write that as a conversion factor. 6 Br2 for every 4 PBr3. 4 PBr3 for every 6 Br2. And we'll use dimensional analysis. So start with what you have, or start with what you're given. 22 I'm forgetting to write the units. 22 moles of Br2. If I have moles of Br2 on top, I want moles of Br2 on bottom. So I have Br2 on bottom here. So I'm using this conversion factor. So 4 PBr3 for every 6 Br2. Moles of PBr and moles of Br. So moles of Br2 and moles of Br2 cancel, and I'm left with moles of PBr3, which is what it's asking me for, and then I just do my math. Plug it into my calculator. 22 times 4 divided by 6, and when you put that in your calculator, you should get 14.67 moles of PBr3. So this is how many moles of PBr3 that are produced when 22 Br2 react. Alright, here's our next chemical equation. 4 FeS2 react with 11O2 to produce 2 FeO3 and 8 SO2. The question is, how many moles of FeS2 must react to produce 34 FeO3? So let's get our molar ratio. FeS2 and FeO3. So FeS2, FeO3 is a 4 to 2. So 4 moles of FeS2 for every 2 FeO3. Or 2 FeO3 for every 4 FeS2. And we'll use dimensional analysis. So start with what you're given, which is 34 FeO3. And if I have moles of FeO3 on top, then I want moles of FeO3 on bottom. So I'm using this conversion factor. So 4 of FeS2 to FeO3. These cancel, and I'm left with FeS2, which is what the question is asking me. And then I plug this into my calculator. 34 times 4 divided by 2, and that should give me 68 moles of FeS2. So 68 moles of FeS2 must react to produce 34 moles of FeO3. Alright, so here's the next question for the same chemical equation. How many moles of SO2 are produced when 67.4 moles of O2 react? So we need to find our molar ratios between SO2 and O2, which is 11 and 8. So 11 O2 for every 8 SO2, or 8 SO2 for every 11 O2. And we'll start with what we're given, 67.4 moles of O2. And if I have moles of O2 on top, then I want moles of O2 on bottom so they cancel out. So this conversion factor is what I'm going to use. 8 moles of SO2 for every 11 moles of O2. And moles of O2 cancel, and I'm left with moles of SO2, which is what I'm being asked. And you just plug this into your calculator. 67.4 times 8 divided by 11. And you should get 49.02 moles of SO2. So 49.02 moles of SO2 are produced when 67.4 moles of O2 react. Alright YouTubers, thank you so much for joining me during this video with Random Chemistry. Please comment, like, subscribe. I really want to hear from you. If there's any material that you specifically want me to cover, if you have any questions, please leave me a comment. Thank you again for joining me, and we'll see you next time on Random Chemistry.